This is the GVSU Team 24 Senior Project video. Our sponsor is DornerWorks, and we created an IoT project. The goal of this senior project was to create a fun application that integrated and demonstrated 5 important and upcoming IoT technologies. The components created during this project will serve as non-proprietary building blocks for future DornerWorks projects. The use of these technologies will allow them to maintain their IoT expertise and accelerate project startup. The 5 major technologies that DornerWorks selected as the focus were Rugix, Raspberry Pi CM5, embedded Rust, PCB design, and mobile app development. The Raspberry Pi CM5 runs the custom Rugix operating system, which is responsible for Wi-Fi onboarding and acts as a relay device between the microcontroller running Rust and the mobile app. Communication between the Raspberry Pi and microcontroller is done via UART, while communication between the Raspberry Pi and mobile app is done through the AWS cloud. In order to demonstrate these technologies in a fun way, the Simon memory game was selected as the application. The game would have the classic physical device consisting of LEDs and buttons, and the game logic would be run by the Rust application. In addition to the physical device, a mobile device was used as a game master that would send the color sequence. Further explanations of these technologies will be given by my fellow team members, followed by a short demonstration of our project.
Now, Rugix is a highly customizable custom Linux OS that targets Raspberry Pi devices. We are using it for the Compute Module 5, which initially it wasn't compatible for. However, we managed to kind of have some workarounds and make it compatible with our project. It also has built-in OTA capabilities, which means that whenever we update it remotely, it will basically download on a new section partition, and it will update that, and if it fails, it will revert to the old one, having some safety measures there. We also have a cool feature where we can remote into it via SSH, or we have a hard debug line that basically just acts as a terminal, so we can debug on the fly. We have an onboarding app which connects to Bluetooth so that we can pass Wi-Fi credentials for the Relay app to work. Now the Relay app will connect to the ESP32 and AWS and allow for message communications to be translated, as well as some other data saving things between games.
When it comes to embedded Rust for the senior project, we wanted to use a core memory, concurrency safe, type checking, and logic protecting language. It was also one of the requirements from the sponsor company. One big issue that we had with the project was determining what variables we wanted to be mutable. That is to say, which ones needed to change versus which ones were needed to be static. The game logic uses 4 mechanical buttons to be able to receive the user inputs. Rust is the programming language that we use to be able to receive signals from those buttons and use in the gameplay.
My main focus was the PCB design. Our PCB is a custom carrier board for the CM5, which directly connects to the ESP32. For the CM5, we connected Ethernet as well as USB-A and a debug UART that goes to a USB-C. The debug UART, the Ethernet, as well as that USB-A is for debugging processes. It wasn't actually needed, but we wanted it for development of the process. Doing the development of the Ethernet, we had to do length matching in order to hit the speeds that Ethernet needs. That was one of the hard parts of doing the PCB. The PCB also has the ESP32, as well as the flashing circuits for it, and a directly connected UART for flashing from Rugix.
My role in this project was developing the mobile app and some of the web systems. The mobile application can connect to the physical device via Bluetooth. It will send over the Wi-Fi credentials needed for the physical device to connect to AWS. Once the physical device is connected to AWS, the mobile app can then control the game logic. It will send over colors that the physical device will then display, and once the user has completed the sequence, the mobile app will receive whether or not they failed or can continue. The mobile app will then send more colors back and the loop continues. The mobile app can also show the leaderboard of the top however many players there were.
Okay, now let's do a quick demo of our senior project. As you can see right now, in the idle state, it lights up all of the buttons in a circular sequence. The button responses and lights are all done by the Rust microcontroller. Now, in order to start a game, we'll pull up the mobile app, and we will click Start Game, enter our username. For this case, we'll call it Demo. And then we select our first color. I select blue, you'll see that it lights up right here. And then we will go ahead and click that, and then it will tell the mobile app that we are ready for another color in our sequence. Continuing this process, we can play the game as a typical Simon memory game would be played. and then we'll go one more time around. Now, if we fail this time by entering the wrong color in the sequence, we'll get a little error. You can see it's telling us it should have been blue, and then we will get game over on the mobile device. Now that the game is ended, let's go ahead and check out the leaderboard. Now that we have the leaderboard pulled up, we can see that there are 3 existing scores. We have Dr. Krug currently holding first place with 10 points. Senior Project has 2 points, and Team 24 has 1 point. If we click refresh, we will see that our recent demo game also shows up, now taking the second place with 3 points. And that concludes our senior project video. Thanks for watching!